Okay, let's talk about parabola function. So remember we looked at the basic shape of parabola. We said we have the equation y is equals to ax squared plus q, and then we looked at the shape of parabola when the value of a is less than 0, which is negative, and then when the a is greater than 0, when it is positive. So we spoke about the sad face, wherein your graph would just have a concave down, and then we have a happy face, which is basically a concave up. So we also spoke about the value of q, which is turning point, y-intercept, and also the vertical shift of the graph. All right, so now we can talk about things like a domain and a range of the parabola. So these are the concept of functions that applies to every type of functions. So if I sketch a parabola here of the equation y is equals to 2x squared, just 2x squared, this means that the value of q here is 0. Then your parabola will actually turn at the origin, wherein you will have a origin of 0 is to 0, and if you look at the value of a is greater than 0 here, hence your parabola is a smiling parabola. So now we want to talk about the domain of the parabola. So basically it means that we look at the values of x of which the graph can take. So if I look at this graph, it is actually turning, but if we talk about the value of x from origin to the left, your function still exists, so it will just go up, but when you go further to the left, your function will continue to increase that direction. And then even if you move from origin to the right, your graph will also have a shape there until positive infinity. So meaning that to write the domain of a parabola, it will be similar to writing a domain of a straight line function, and you simply just say x is an element of real numbers. That's it. And we talk about the range. So the range here, it means we talk about the y values of the parabola. So y values for parabola, we will have to look at the value of q. So if you look at the function here, your parabola doesn't exist below x, is below the x-axis. So if you check here, it turns at origin and then it goes back up. So anything below x-axis, there is no function. So meaning that you look at your turning point and then you can be able to identify the range. So for this example, I can simply say that the range is y is greater or equals to 0. And basically the reason I say 0 is because it is turning at that point. But if I have maybe a different graph, which is y is equals to maybe x squared minus 2, this means that here the value of q is equals to negative 2. And if I sketch the graph, your graph will basically have a turning point at negative 2. And then if I sketch, your graph will actually go and turn here, and you will have a turning point right there. Now I want to write the range for this function. So we see that the value of q is not 0 this time, it's negative 2. And a graph, when it is negative 2, it starts there and then going upwards to positive infinity. So when you write your range, you will just simply say that the range for this function is the same as y is greater or equals to -2. So -2 is included in the range, and that is because you still have a function when y is equal to -2. So hence we have a greater than or equals to as a sign. So you should always include equal sign when you write the range for the parabola. So sometimes you can also have your graph that might be facing downwards, so meaning that when the value is of a is less than 0. So we can look at a function, maybe we say y is equals to maybe -x squared plus 4, for example. So I can also draw this function on here, and then I put 4 up there because it's positive, and then since the value of a is less than 0, it means your shape is a Z function. So you will have your graph that would have a concave down like that, and then you will have the maximum turning point there. So y is 4 is going to be the maximum value for this graph. So, and then I asked you to write the range for this graph. So the range for this graph will be y is less than or equals to 4. So what does this mean? So whenever the value of a is negative for the range of parabola, your range will be always be y is greater or less than or equals to the some value q, right? Because you will have a set parabola all the time. That is how you write the range when a is less than 0, for example, in reference to this graph. But if a is greater than 0, then your range will be y is greater or equals to q, right? So look at the value of a first, whether it's positive or negative, and then after that you will be able to see the value of, or you'll be able to identify the range of the graph. Whew. Okay, so what are we doing now? Okay, so now we have done looking at the range of the graph. Another thing that we can talk about for parabola is basically how to get the equation of the graph. So if I can try to have an example equation of a graph. Okay, so maybe before we get to the equation of the graph, let's just try to use the equation of the graph to sketch the graph itself. So maybe I have y is equals to minus x squared plus 4, and then this is the equation of the graph, and I need to sketch it. So maybe the questions that I can have here is 1, determine x-intercept of the graph, and then secondly, write down the turning point, and then the third question I can say write down the range of the graph, and then maybe fourth, I can have sketch the function, right? So these are some basic questions for the graph that we have here. Okay, so now what will happen here is since we have to talk about x-intercept and y-intercept of the graph, maybe let me put the last question, but it was supposed to come here in the middle, but I'll put it at last, and then I say write down y-intercept of the graph. But it's not really necessary for the parabola to talk about the y-intercept, because the main focus on the parabola is usually like turning point, but we can still talk about y-intercept, but not that much. So now I can start to answer the questions right there. So let's say for the first part, I need to get the x-intercept of the graph. So one thing about parabola is that you need to be able to know how to solve for x whenever you work with parabola function, like your quadratic, like difference of two squares at most. That is what you need to know. So remember, when we determine x-intercept, we let y to be 0. So I will take the equation negative x squared plus 4 is equals to 0. And then after that I can try to factorize this, but as you can see that the value of a here is negative. So what I will do is I'll factorize the negative, and then I'll have x squared minus 4, which is equals to 0. And then after that I can divide both sides by -1, so that I get rid of this negative right there, and I'll be left with x squared minus 4 is equals to 0. And then after that I can basically just factorize by difference of two squares. So this is your solve for x part of the algebra. So you have x minus 2, and then you have x plus 2, and then you can write x is equals to 2 or x is equals to 2, actually it's -2 right there. So you have the x-intercept of the parabola. Now I need to write down the turning point. So remember, the turning point of parabola, remember we say that is usually represented by the value of q. So our value of q there is 4, so meaning that my turning point in that function is going to be 0 is to 4 basically. And now I can look at the next equation. It says write down the range. Usually for parabola they are interested in range, since it can be a bit tricky. It's not like the same as for the straight line. So here it means that range is more important to us than like in a straight line. So the range here will be like looking at the value of q and the fact that our value of a here is less than 0, then it means that you should know that the range should be always be less than or equals to 4. That is the range. But me writing the value of q here doesn't mean that this is how you get to the answer. I'm just trying to indicate that q is going to be dependent on the value of a, whether it's less than 0 or greater than 0, in terms of whether you use a greater than or equals to, or you use less than or equals to. So for this case, the value of a is negative here, as you can see, is -1, which is minus x squared. So which means you have a which is less than 0. Therefore the range will be y is less than or equals to 4. Then to sketch the function, then I can just have my graph as follows. So you can just put the value of q right there, which is +4, and then you also put the x-intercept -2, and you have +2, and then from there you can just sketch your graph, and then it will have a Z phase like we expected, since the value of a is less than 0. And then from there you can have your y-intercept. So basically y-intercept is also the same as turning point. So you will just say that y-intercept is equals to, you can say just like y is equals to 4. So, or you can basically just say 0 is to 4. Okay, maybe writing a coordinate is actually much better, because y-intercept is basically a coordinate, or you can, anyhow. So whether you can say y is equals to 4, or you can just write the x-intercept as a coordinate, it's okay. But maybe let me just say y is equals to 4, is gonna be my y-intercept. Okay, so that is how you will be able to sketch a parabola function when you are given the equation. Now we will look at how to actually analyze a graph. Okay, maybe if I am given a sketch of a graph, and technically I just want to identify the equation of the graph. So I can sketch a graph here which is gonna have -3 and 3, and then maybe it has a point here of -9, and then you will have a drawing that looks like this. So this is your sketched parabola with some y-intercept or turning point, and then you also have the x-intercept, and then you have your equation as y is equals to a x squared plus q. And then we have the following questions, like one, determine the equation, or you can actually just say determine the values of a and q. So this means that from this you can say that you have a value of a and q that we need to know from the diagram. Number two, maybe I asked another question like write down the range of the function as well. The range, I'm also bringing it back. Then number three, maybe what can I say, write down, maybe this one is gonna be the bonus question, write down the values of x for which the function is increasing. Right, so now I know the last one is a bit new from what I've been talking about, but we'll see how to work around it. So you need to look at the points that you are given on the graph so that you will be able to find the values of a and q. So technically here you can see that you have a point which is 0 and 9. Okay, actually this is -9, and at this point you have x value, and you also have the y value as well. So you can basically substitute that on your equation, right? But before that, you can actually know that the value of q is obvious. So if I write this equation, I can simply just substitute q by -9. So I'll have ax squared minus 9. Right, that's what I have. So I will be left with determining the value of a in this equation. So this is the part wherein, let's see if I can take a value of 1 point on the x-intercept, and then we try to substitute that so that we can find a. So the point that we have here, maybe I say it's 3 and 0. So you will have y here, which is 0, and then you'll have x there, which is 3. So I can take this equation and substitute for y and x. So this means that I will write 0 is equals to, then I have a, then I have 3 squared minus 9. Then from there I can take the value of -9 and substitute, transpose to the left, which means I can have 9 is equals to a, and then I have 3 to the power of 2, which is 9. So I want to find the value of a, so I'll divide both sides by 9. This will cancel that, and then this will be the same as 1. So 9 divided by 9 is 1, and then we'll have 1 is equals to a, so meaning that a is equals to 1. So as a result, you were able to find that a is equals to 1, and then also q is equals to -9. So whenever you need to substitute, or actually to determine the value of a and q on the parabola, and you have some points on the graph, if you have a turning point, then you can easily just write it there, because you don't need to calculate it. It's always there. It's your turning point, so it's just gonna be the exact value that you see on the graph. And then to find the value of a, you take 1 point on the x-axis. So I chose this one, but you can still use this one. It's still okay, because any number squared is always positive. So even if I was using -3 here, I was still gonna get 9, since -3 squared is 9. And then you just divide both sides, and then you can get the answer for a. Right, so we were able to answer the first question. And then second question, write down the range. So obviously, maybe the range will be y is greater or equals to -9. So here you can see that the graph is a smiling parabola. A is greater than 0, it's positive. So it means that you will have to use greater or equals to write the range. And you can see your function turns up at -9, and then it goes upwards. You do not have a graph below -9. So this is the range of the function. And then write down the values of x for which the function is increasing. So remember, we spoke about increasing and decreasing function on a straight line. So for parabola, the other part of parabola is increasing, the other part of parabola will be a decreasing part. So remember, when a function is decreasing, it means from left to right it goes downwards. So if I look at this first half of the parabola, you can see that since it's turning at this point, from this point going to this point here, like let's say like -infinity to 0, your graph is decreasing. So this is a decreasing function here, this side, decreasing. And then from 0 going to +infinity, your function is increasing here. This is an increasing shape. So it is going from left to right, but going upwards. So how do you write the values of x? So it means that from 0 towards the +infinity. So for 3, it means we will say that the graph is increasing when x is greater than or equals to 0. Right, so this is how you answer this type of questions. So but this one is just an additional one, just for extra knowledge and just to learn how to see where your graph is increasing and where your graph is decreasing. So if I was to say values of x for which your function is decreasing here, then it means I was going to say that x is less than or equals to 0. So your function is decreasing from 0 towards -infinity right there. So this is so far what I can do with parabola. I hope it will be able to help you understand some bit of parabola, even though like I didn't do much of it, but hopefully it will do a difference in your understanding.